Hello students, welcome back. So as we have been discussing the topic of matrices and determinants, today we will be switching to the next topic of matrices, that is minors and cofactors. See, these topics are quite interrelated. So this topic is also in fact based on the concept of determinants. So do refer my previous session before you attend this one, right? So what do we exactly mean by minors and cofactors? See, okay, first I will be dictating the mathematical definition. The definition says that the minor of an element is basically a determinant but of lesser order. Note here, lesser order formed by excluding the row and column of the element. And it also says if we leave the row and column passing through aij, if you remember, aij means the ijth element, then we obtain a second order determinant which is minor of aij and is denoted by mij. So how do we denote the minor? We denote it by this symbol mij, capital M subscript ij, which denotes the minor of ijth element. So what is it exactly saying? That suppose I take this element a11 and I wish to find out the minor of this element, then what you need to do is, this is for your understanding sake, you just need to cancel this row and this column. The row and the column which intersect, which coincide at that particular element, you can cancel out those, and the remaining determinant, the remaining part, is known as the minor. See, this determinant, if you find out of the remaining elements, this will be called as the minor of this element a11. The things will be more clearer, just wait. So next we have is, in general, minor mij of an element aij is the determinant excluding ith row and jth column. This I have just now discussed. So we have 9 minors corresponding to 9 elements. Corresponding to each and every element, you can get one minor. So in total, we will have 9 minors for a 3 cross 3 ordered matrix. Okay, so we find out the minors. If you wish to find out the minor of a11, this is the general matrix a11, a12, a13, 3 cross 3 matrix I am taking, a21, a22, a23, a31, a32, a33. So if you wish to find out the minor of a11, what we'll do is, we'll just exclude the row and the column which coincide at this element. So that means we'll exclude this row and this column. So the determinant of the remaining portion, this portion, see, a22, a23, a32, a33, this is the minor corresponding to a11 and is denoted as m11. Similarly, you can find out the various other minors, like we can have of a22, a31 and so on. So, and what is the next concept is that of a cofactor of an element. So cofactor of an element aij is defined as cij, like we had mij, now we have cij, which is defined as this. So what is basically the relation or the difference, you can say, between cofactor and a minor is that of a sign. Cij is -1 raised to the power I plus j mij. So if we put a sign, the corresponding sign with the minor, we get the cofactor of the particular element, where Cij is the cofactor of aij. We'll be discussing this with the help of various examples. Okay, things will get clearer with the help of this. See, if A is a square matrix which has elements a11, a12, a13, a21, a22, a23, a31, a32, a33, this is a 3 cross 3 matrix, then if we wish to find out the minor of this particular element, just cancel out this row, this column and the remaining element, that is this and this. The determinant of these elements will give you the minor. So this is just after deleting the row and column you get the minor, and cofactor as we have discussed is minus 1 raised to the power I plus j mij. Okay, so here we have basically tabulated the various minors. You can easily find out, we have already discussed determinant of the remaining elements. This you can easily solve out for the general 3 cross 3 matrix. Okay, so we have in fact already discussed the concept of determinants in the previous session. Here we shall discuss what exactly is the relationship between determinant and minors and cofactors, or how you can find out the determinant with the help of minors and cofactors. So to find out the determinant of a 3 cross 3 or maybe a larger but square matrix, note here that it has to be a square matrix. Choose any row or column. Multiply the minor of each element in that row or column by plus 1 or minus 1 depending on whether the sum I plus j is even or odd. Then multiply each cofactor by its corresponding element in the matrix and find the sum of these products. This sum is the determinant of the matrix. I am sure you wouldn't have understood it by this. So we will be discussing it with the help of examples, and I am sure you will be able to understand it. See, so we have an example in this context to find out the determinant. Suppose we have this 3 cross 3 matrix and we wish to find out its determinant by expanding along the second column. Second column is this one. So either you can expand it directly, as we have already discussed in the previous session, how do you find out the determinants, or what you can do is you can first find out the minors of each element in the second column. So we'll start with this, we'll take up this element. Now in order to find out the minor of this particular element, as we have discussed, what you will do is you will just delete this row and this column. That will be the minor of this element. So we are left with the elements minus 1, minus 3, 2. Let's see. See, here we have minus 1, minus 3, 2, and determinant of this gives m1, 2. So we get it as minus 5. Similarly, you can find out of minus 4, then you will find out of 0. See, for minus 4 we get it as m2, 2, we get it as 2, then we find out m3, 2, we get it as minus 8. So next you will have to find out the cofactors. So how do we find out the cofactors? Cofactor means C12 is just minus 1 raised to the power this subscript plus this 1 plus 2 into m12. So minus 1 raised to 3 is negative. So we have minus of, we had minus 5. So minus of minus 5 gives 5. Similarly, you can find out C22, then you find out C32. So what you have done is you have already found out the minors as well as cofactors. Now how do you find out the determinant? This is the formula to find out the determinant with the help of cofactors. It is, since we are expanding along the second column, so what we have is A12, this element into its cofactor, plus next element is this into its cofactor, plus similarly this into its cofactor. This gives us the determinant as minus of 23. So it was quite simple. I am sure you would have understood it. Next we have is properties of minors and cofactors. So the first one says the sum of products of elements of any row with the corresponding cofactor is equal to the value of the determinant. This means if you multiply sum of products, first you multiply the element with its cofactor and then you find out the sum of all these terms, this quantity will give you the value of the determinant. Just note here the word corresponding is important. You multiply A11 with its corresponding cofactor, then you add into it the product of element A12 and its cofactor, and similarly so on. So this quantity will give you the value of the determinant. This is an important property. So next one says The sum of the product of element of any row with corresponding cofactor of another row is equal to 0. This means if you have an element, you multiply it with a cofactor of some other row. See, these elements are of first row, while these cofactors are of second row. So such form of quantity will always be equal to 0, right? A11 C21 plus A12 C22 plus A13 C23 will be equal to 0. Next property that we have is, if the order of a determinant is n, then the value of the determinant formed by replacing element by its cofactor is determinant raised to the power n minus 1. These properties are quite important and I would advise you to learn them all because they often prove useful in various questions, right? Okay, so that was it for this session. I hope you would have understood the concept. The concept was quite simple, and do stay tuned for my future sessions as well, as I'll be switching to various other topics like adjoint of a matrix, then we'll be switching to inverse of a matrix, system of equations. Thank you.